Hey guys, welcome to part 3 of eBPF programming. And in this part 3, we will be continuing exploring LSM with eBPF. And in this session, I will be sharing how did I develop an application that helps us to prevent local privilege escalation attempts in Linux. Not only prevent, you can detect also. But till last video we were dealing with how we can detect stuffs and how we can share data between the kernel space and user space. In this application I did in a reverse way. I was setting up my values in user space application and I was sharing that to the kernel space. And the other change in this one is till now, because we were listening for kernel events with a loader and it was in a continuous loop because we had to get values from the kernel space. In this one it's just preventing, so we don't do that infinite loop in the user space. Instead we just run the application normally without any hardcore infinite loops. But of course if you want to take data from the kernel space, you have to put that in an infinite loop. And here in the third part, as I mentioned, we are exploring more on LSM hooks, and the hook that I'm going to introduce you today in combination with eBPF is BPRM check security. And this hook is called during the execution of any new program in Linux, specifically after the binary format has been recognized. So suppose if the ELF or any other script or shell script or Python script, whatever it is, after the format has been recognized, this gets called, and the good thing is it's executed before the process is fully set up. So this hook is basically checks security, whether that program is allowed to execute or not. And you can put your own logic here in this hook if you have additional logic to implement here. Normally in LSM you can create it as a kernel module by placing your security logic here in BPRM check security hook. And the thing is, it's just calling after the XOP system call, and it executes every time in the script. So whatever kind of binary ELF or scripts, whatever is getting called in Linux. And this is a flow, a process that normally calls execv. Actually we have covered this one in the first part and a bit on the second part too. And then kernel creates this structure, Linux bin PRM. Yes, I think it's binary permission or something. That's what I believe. Oops. And then the process, the flow is like it identifies the binary format. Then here is the main point. It calls BPRM check security hook, and I put my eBPF logic here in this hook, and it checks for the security, and if it passes, it loads a new program, and if there is some access control issues there, it return error to the user space. And replace the process image and start a new program execution. And this is a signature function signature of the hook that I'm going to use in this program, BPRM check security. And here we have to pass Linux bin PRM structure as a pointer, and it checks the security. This hook allows security modules to perform various checks, like verifying the integrity of the executable or checking permissions beyond the normal DSC. And the main thing is you can enforce additional instructions based on the security policy. And you can have your own policy enforcement, and if it is successful, it always return a 0. And if there is any negative code or error, normally error code is a negative value, so if in case of error, it returns a negative value, so that fails and it blocks you there. And regarding the parameter, as I shown here, this has Linux bin RPM as structure as a parameter of this hook. So regarding that, it stores a lot of information, that is file information, memory information, argument and environment data, executable format information. I'm making use of I think I'm making use of user ID, and I'll show you the program that how did I create that for blocking normal Linux parallel escalation using sudo commands. So as I mentioned earlier, when the program is executed, it creates this Linux structure, and this structure is passed through various functions to fill it with necessary information. Like whenever it's passing through different processes, actually this structure is not really used here in this hook. It is used on several process flows, like till the process is allowed to run successfully. This structure is getting filled with different information. That's all about the theoretical part of this one. Let's jump into a code side now. And believe me, eBPF programming is really frustrating, especially if you are a beginner. And the reality is that LLMs are really bad in this eBPF side, and most of the time I don't know, eBPF help when you're asking help to ChatGPT or some other LLMs. It comes up with very old information. Like I got really stuck with on those side, but sometimes it helps, like basic stuff. If you're missing some basic stuff and some the error code that suppose if you're facing some error while loading your eBPF app to the kernel space, those kind of situations, sometimes it helps, but otherwise it sucks. So here is our program. If you have seen my previous videos, these are the basic stuff that we have to include in. But we have to mention the license, and here I am defining my constant. I just declare this one just to as a part of my testing, because this was a headache when I initially put 256 here, and the story was really frustrating. And I was using a new function that I came across. It was BPF path. What it was doing is, the good thing about this function is this will give you the exact binary name. Binary means like I have to show the difference. In fact, when I'm running this application, I will show you the difference. Here you can see I'm taking the file name. This file name, normally I'm getting, suppose if it's a binary related file name, then I'm getting a symbolic link here. Is not the actual binary that is representing the file inside the file name. But when you are using this function, BPF path, it gives you the exact binary name. As an example, normally when you type Python, this file name will have user bin Python as a file name, but that is not the actual file name. The actual binary name is user bin Python 3.11 or whatever version that we run inside the Linux. So if you want to get that exact binary name, you have to go with this one, but this has big issue. Like here my logic is I'm filling my binaries that is not allowed to run as sudo from the user space. So when I'm taking the value from the user space and I'm checking the current binary name, whether that binary is in my list. If it's there in my list, I won't allow to run it. That was my logic, and it was very simple when you are thinking in normal programming world. But here it was a mess for me, because when I was fetching the file name from using this function, actually I was getting the file name. Suppose imagine you have an array of 21 character array, and if you are fetching this file name, using this function. Suppose if you are checking for a cat command, then you will get user bin cat as your binary name. Then just after that there will be a null terminator 00. Then /0 normally in hexabyte is 00. Then after that till the end of this array, you see a lot of junk characters. I don't know, I have to dig deeper into this function. Most of the time what I see was like sometimes it was /n, then again repeated the command path till, like if it's bin user bin cat, then null character, then after that it comes again, it continues with bin cat, like that. So the problem with that one was I am filling my map from the user space with the exact file name, like user bin python. Then this one, when you are printing to the console, the print k, BPF print k, the debugging function consider the string till the null terminator. So when you're printing to the console, you will never get the differences, what exactly going on with the string. And it was frustrating. I didn't get any clue on how can I go with this one. Then here actually ChatGPT helped me. I got a suggestion from ChatGPT that to just try to print out each byte from the character array, then I can find out the reason. When I try to print this array, then I realized that this function is reading the exact file name, then the null character, and after the null character it was filling with a lot of junk values. So that's why I didn't use this function. But there's a workaround on this one. Workaround is you have to declare another character array, and I tried that one. That was working, but in performance ways that will be an issue. Like you have to declare exactly the same character array once again, and then you have to read this to your normal variable. Suppose if it's f name, then again you have to do a read kernel string BPF helper function to the new variable from our junk valued variable. So the good thing about this function is that it creates when you're trying to read the string, it fetches the value from the specific place, and it properly null terminates it, and it after the null termination there won't be any junk characters. That's the better part of this one. But the problem with this one is this one is not giving the exact file name, exact binary name. I tried with, I don't know how this function, I have to look into the definition of this one, how it is reading the exact binary name. So we can implement that directly here. But in this case I'm just using kernel string function, this BPF helper function, to read the BPRM file name. This file name is actually the file name that is going to be executed, because we are hooking before the execution of the actual binary. Whatever binary is going to be executed or command, whatever it is going to come here, and we are fetching the file name. And I'm checking and this BPRM and everything is here in this vmlinux.h. so if you search here, you can get more details about this one. See, it's declared here. You can just go through this one. It has 3 file structures. One is executable, another one is interpreter, and the file itself. Then there's a credential CRD structure that has also a lot of information. I'm making use of that to check what is the current value of the UID and effective EUID. EUID means the effective UID of the binary that is coming here to run. We are getting all these things before the actual binary is going to run. So I fetch all these values, and this one I just I was reading it for my reference. I'm not using it here. And these are the things that we can fetch from the BPRM structure for this function. And I'm checking, of course I need to check the parent task. Like whenever see how this function works is like, suppose if you are running a command like sudo and ls, then this hook will get called 2 times. One is for the sudo and other one is for the cat. So when the first time when the hook is getting called, it shows that the file name as user bin sudo. Then the next at that time the sudo will have the UID of the current user. Suppose if it's going to be run with my username, the UID will be my username UID. But next time, just because we supplied with sudo cat, the next time the cat comes, but the cat will have the UID as 0 because we elevated the cat command's UID with the sudo. So that's why I'm checking every time when it comes here what's the parent of the command. If the parent is running as root, like suppose the command is coming like sudo cat, and that is entirely different from when we are running directly a cat from the root prompt. So when you are directly running the cat from the root prompt, the parent process ID will be always 0. So that's why I am fetching the parent from the task structure, the real parent, and I'm checking the command on that. I'm not using this command. I have to remove a lot of codes from this one because this code I was checking and learning all these stuff, what exactly all these stuffs contains. And this is the main thing I'm using. I'm just checking the parent UID. That is, the parent UID is there inside this CRED current structure. So you will get the parent UID from here. And if the parent, I'm printing those information here, and I'm running this, I will show you exactly what's happening. And if the parent ID is 0 means that means somebody is running the command directly from the root prompt. So in that case, we are not checking anything. We are just returning 0. That means the program continues. It allows to continue the program. But if in case, I already told you I'm filling this map from my user space. And regarding this map, last time we explored how to use a ring buffer, and this time it's a hash type. Hash type means it's kind of a key value pair, and my key is a character array, and value is like a integer, but it's kind of dummy values because I don't use the values here. I'm using the exact keys here. So we are checking for if this map that is filled from the user space, if the map has some file name that I already mentioned from the user space that are not supposed to be run. So if it found, it returns a pointer to that key. Then if there is something, then it checks whether the credential UID. Here, this one I am fetching from here. See here, this is we are getting from the current binaries UID. This is a current binaries UID. Suppose imagine when on the scenario like somebody is trying to run. Suppose I'm going to block a well-known command is find. In find you can using find you can escalate privilege using the exec command. You know that, right? So when we try to run find from a normal prompt, the UID will always be the user's UID. But if you're trying to run the same using sudo find, the UID of the sudo will be my user ID, but the find will have the UID as 0. That means if somebody is trying to escalate the privilege. So in that case, what we are checking is whether the parent UID is 0 or not. When it comes the sudo's parent, sudo or sudo, I don't know. I'm just used to sudo. So if that sudo command has a user, as a 0 as a UID, then it continues. Normally it won't be the case, because sudo will always be executed from a normal user privilege. So in that case, this will not be passed, and it comes here and it checks the map, and if my binary is allowed there, if it found my binary there, and it checks for the current credential ID. Current credential ID means the current credential here is the exact command. In this sudo find case, it will be find, and of course find will have the UID as 0, because we escalated the privilege using sudo. So in that case, it says, yeah, it just prints this attempt, and the important part is it's returning a negative value. Returning a negative value, I already mentioned inside regarding this hook. If the hook is successful, it returns a positive 0 value, and if there is a negative value, means this is not supposed to be allowed. So thus it blocks that execution. Like all these stuffs, I had to remove all these things. I was just learning stuffs what exactly inside all these different structures and values. Now let's jump into our loader function. Here I'm using a part of the skeleton file. Till this one, if you didn't see my previous video, I'm just saying again this one, you have to raise your memory for this one, and it should be the same as the file name length should be same as your kernel space application. And till this point everything is same. We load, we attach, and after that, here is the main point. We have to fetch the file descriptor for this one, like file descriptor for the kernel function. In the sense, not kernel function, file descriptor of the kernel map. Here in this case, my map name was not allowed bins, and if you come here, you can see I can access the map from the skeleton structures maps, and from that I can directly access not allowed bins here, because this one is defined here. If you check here and not allowed, see, you can see the loader structure has these numbers, and inside the loader structure you can access the maps. See, these are the maps, and if you want to see access exact maps, you can say loader dot maps dot and this function, this map name. That's what I done here. And if you are not following this one, I know it's a pretty weird programming normally, if you ask me, but it's really good, and it's once you learn it, actually you really love it. And this is nothing but I'm just getting file descriptor for this map, because I'm using this function. This is a user BPF helper function. This will return the file descriptor for the map. I need the file descriptor for writing to the map, and I'm finding a file descriptor from here, and if it is returning some negative value, that means it has some issue. And this is another thing. See, for all the values I'm using this not allowed as 1, because here in the key value pair, the value doesn't have any meaning here. I'm just using the key file names that helps us to run, to check and run the program. So once I get the file descriptor, what I'm doing is I'm creating another array with my binaries needs to be blocked. This is the thing I mentioned in the beginning, because the bin bin RPM BRM BPRM. The BPRM structure file name is giving me the symbolic links, but as I mentioned, if you go with this one, BPFD path, this will give you the exact binary name, but that needs an extra step of creating another variable and correcting the string for setting up the map look. Otherwise the map lookup will fail. So I'm just making use of the symbolic links and I'm just entering all the possible values of Python. Python may have Python and Python 3 as commands, and I'm just blocking another 2 binaries. These are the possible, normally attack is tried to escalate privilege using these binaries, whether it has some interpreters or maybe using the find command. There are so many other things that you can add to this one. Definitely that will work. The constraint for this one when you're developing using user space in C programming is that it's not as convenient as Golang. You may need work on a lot if you want to get the flexibility of Go. Definitely on my next move is to Go using Cilium framework. So in that, when I'm using that, I will show the difference on this one. Here anyway, I'm just using this array as my binaries that needs to be blocked when it's going to be executed using sudo. So I'm just adding this one, 0, 1, 2, 3. I have 0. Actually, it should be 4. Because index starts with initially I didn't have this Python 3, and that's why I was using 3 here. This should be from 0 to 3 to cover all this. Just string copying the to my key. Key is nothing but here I declared the same type of array that I'm using in user space, and I'm just initializing it with zeros just to ensure that there is no junk values going to come up. And this is info. Actually this is not needed, because normally when you are copying using string and strncpy, the null termination will be there automatically, but this is eBPF user space, so I'm just enforcing it to do the null termination. This basically is just copying all these 3 values to the map, and here after copying to the key, I'm doing the map update here. See, I'm just using the file descriptor that I fetched from here using the BPF map file descriptor, and then I'm writing the key, the string copied value, and I'm just passing the address of not allowed. This one is nothing, it's a dummy value, and this is a flag that I'm using to update the map. That's all. And if you see here till the previous programs, we were using an infinite loop because we had to fetch information from the kernel space to the user space. Here we don't need any loop like that, because we are not taking any data from the kernel space. Instead we are writing to the kernel space from here. But suppose imagine it's going to be a detect and prevent method, then definitely you have to be in an infinite loop, and you have to fetch information from there. When you are getting blocked, when the prevention is done, you have to fetch information to the user space, and you have to store it somewhere for further analysis. That should be a perfect way of doing it, even though the prevention, here I'm just showing it prevention, just adding data from here to there and just prevent it. We don't need any more data, because the ultimate aim is to prevent the local privilege escalation. But yeah, definitely on the next version of this program, I'm planning to do it in Golang using the Cilium framework. I have to add those functions, like this should be in a loop, and same time I have to send this data to the kernel space, and I have to fetch the information from the kernel space to find out which user is trying to do that. So this is the thing that's happening in user space, and I hope you know how to create all these stuff, skeleton files, header files, that I have covered in the first 2 videos, how to create that. And that's the logic of this one. So now let us try to run. Here I have 2 different 2 different terminals that has, one is current exact root and the other one is having a normal terminal. So what is going to happen, let me show, before I'm going to run the eBPF, let me show the privilege collection attempt. Okay, I'll show with Perl. Let us try Perl, and it is nothing but it's trying to run Perl, and we are utilizing the Perl's exec command to run the bin bash and using the sudo privilege. So if it's allowed, and one more thing, here in my, this is a developer machine. Normally in developer machines you don't see any restrictions on any interpreters, because see, this one is not at all allowed. Like, this one is not at all an ideal way of setting it up, but it's for the, normally this will be the same for, I think, for developer machines, because developers needs more privilege on running most of the interpreters and other their programming stuff. But if this is the case, we can easily make use of this one. I try here. Did it work? Oh, no, it didn't work. Oh shit. I think I did paste it wrongly with extra characters. No. Oh, did I make any mistake there? Oh, is there any syntax error on this one? Exec bash sudo early. No, this some syntax issues. Is it it's like this or no? Oh, I had to find out what was. That's the reason I just copied it here. I think I didn't again make. Okay, I'll try this one. Find happens in demo. It might be very some small mistake on the syntax. Okay, let us try this one. Yeah, see here, this one didn't have any syntax issue, and it's just using the find command. We tried the exec, and we told it to do this exec, run this binary as, because we use the sudo, the find did this as root for us, and we got this this shell. And let me try the Python now. Hope it doesn't have any syntax issue. It seems so, but yeah, let me try this, and yeah, I'm letting you to find out the issue on this one, maybe some other way. Let me try this one. Oh, again, this is it coming like this, or is it part of some update? I don't know, or I'm making some mistake. I have to Google it to find it out how exactly. I think there are a lot of resources to find this stuff. what exactly the syntax issue on this one, but it was working till yesterday. Or I did try some other. Let me check. History grep Perl. Let me try Perl first. Did I? This is today's. Oh, this one from this. I think I did it a lot of stuff. Of course you can grep properly, but this one is not so. So this should be the command. I hope so. I don't know, maybe some syntax issue. You can try to find it out. Anyway, I got it using find, so I can show you. I can show you how can we prevent it. But I'm wondering, it was working for me till yesterday. I don't know what happened on this one, but if you find out the issue on this one, the syntax or something else, or some other update issue or something, you just let me know. It was working for me till yesterday. So that is fantastic. It is not even showing history grep Perl. Yeah, Perl. Let me try this one. Is this the same way I did, or did I do some other mistake? No, it's not working today. No idea what it is. It was working. Oh, this is the one I changed, I think. What about this one? The same thing, right? I didn't do any syntax changes. Oh, see, maybe what was the syntax issue here? Did I do the same thing here? Sudo Perl. Okay, let me copy this one. See, it might be Perl exec -e exec bin bash. Okay, I'm just missing. Okay, I'll update here. It should be like this. I was putting the semicolon before. The semicolon should be after the double quote. Yeah, so it should be the same case for. It's good that I got it, because otherwise I have wondered what was happening. Then just grep Python. What was a Python command I was using? This one, maybe this. Is there any difference? Bin bash spawn. Basically it's just spawning a shell, but yeah, of course it will. Why it's not showing? No. then it might be the other one or the same thing. I don't know, something happened to the Python C import. Oh, okay, the single quote issue, wastage of time. Yeah, see, again this one had some issue. I had to replace this also. Oh, I didn't have any issue. Okay, so here the scenario is like, before I was running this eBPF, my eBPF app, I was able to do all these stuffs. Now what we are going to check is what's going to happen when we run out my eBPF and if we try to execute the same command after that. So on this one I'm going to run my eBPF app. That's going to, if everything goes successfully, is going to run and load and prevent this. Yeah, these are the values I put. I had to remove this stuff. This find Perl, Python 3 and Python. We have put 4 values here, and if you want to see what exactly, suppose you can check your map values are loaded correctly from the user space using show map. You will lost again the syntax. So map list, and on the map list you can see not allowed bin is loaded and the map ID is 77. And if you want to see that thing, you can using the dump map with the ID dump and 77. No, okay, dump map ID, maybe it needs ID. No, okay, dump map, oh sorry, map dump, all this, no, I don't remember these things. Dump map, see, you can ensure that if your map has filled successfully from the user space, you can see it here and you can ensure that everything works fine. Now we have the map filled with 4 values, and if the user is going to try to run any of these things using the sudo command, it should be prevented. So just to see our debug information, I'm just taking the debug information. Sys kernel tracing trace underscore pipe. Here itself we can see when it's loading, the bash is having the ID as my user ID, but you can see here when it comes, I use sudo cat. So the sudo is running with my user ID, but the user bin cat has UID as 0. That means after the sudo it got escalated the privilege and the cat is running as 0. So what we are going to do is, so we just run a normal find here and see what happens. See, it allows normal bin find UID is my user ID, so no problem. Perl, even Perl is allowed because of Perl is getting 1000. Python 3 for this, yeah, it's running, and Python it should be, because all these have the normal user ID. Like I'm trying to run it as from my normal user perspective, but now what happens, okay, let me show you the other one. Like now we are on the root shell, and suppose I'm going to run directly from the root shell Python. It should run because it's not as an attacker perspective, when he is getting a shell, if it's going to be a direct root shell, then we can't do anything on that. But if it's a normal root shell, yeah, definitely the application is checking. This scenario, it's a direct root shell, so we are not doing anything on that in eBPF, because we explicitly check whether the parent process has a user ID as a normal user ID, and the current process is running as root user. So in this case, in the root shell, everything is on root, because the Python itself is getting the UID as 0, so it won't block anything. But I will show here this case sudo, and if you try to repeat the same thing here, and let me copy this. I'm trying here. See, this is blocked. I already shown you before my eBPF app was running, you were getting a root shell, and now it is getting blocked. And here you can see that the information that we are printing here. Now the bin find got UID as 0, but the sudo is having my user ID. So in this case, I'm checking whether the parent process user ID is not root user, and the current process user ID is 0. That means we are using sudo or some kind of elevator privilege application to run this as root. Then we are permitting it. The same thing if we try with this one. Python. Oops, didn't copy that. See, it is blocking Python, and you can try the same in Python 3 if it should be blocked. As I said, I was getting the BPRM file name as a symbolic link. That's why I use other Python and Python 3 here. And yeah, of course, it should block Perl also. It should be, because there is no big difference, because we already where is that? See, all these things got blocked because we supplied because our map has these values. We are saying to our eBPF that if the eBPF is seeing these 4 applications running with elevator privileges, you should block it. But when it's going to run directly from the root shell, nothing should be blocked. It should run as normal. This is a way you can develop applications. I mean, I learned stuff like learned a lot of new things here, especially the difference between how the kernel strings are getting read by this BPF read kernel and kernel str, and what is this BPF deep path. This was the most annoying part, and I couldn't figure it out the exact reason for I think for more than 2 days, because I was blindly thinking that this string will never get any issue. That was not in my thoughts. But yeah, after printing out each characters of the string, I figured out the issue, and then again came back to. But this one definitely we can make use of. But yeah, the performance issues will be there because we have to remove the extra characters from the string to make sure that our map lookup will never fail. If there is any mismatch on any of the single characters, definitely the map lookup will fail, because we are using key as the character array kind of like normally it's a string, so it should match every characters inside the string. So if you finding any mismatch on character array, it will never fire. So that's all about this one, how to prevent some Linux applications using eBPF application using LSM hooks to prevent privileged connection attempts. And yeah, that's it for this video. I will come up with another interesting application and I will share my progress with some other stuff. I'll soon put this in my GitHub. If somebody wants to try and want to learn from this one, yeah, you can. And yeah, nothing more on this video. I think I have covered everything that I planned for. Yeah, that's it for this one. So I will come up with another eBPF experience on next part. Till then, it's a bye from Alphas.